Hello, welcome to Jet Mathematics. I remain your host, Milton Ebiwari John. In this video, we'll be looking at logarithmic equations. Okay, we have two examples on the board. We'll quickly solve them. The first example says, given that log s to base 2 plus log 81 to base 3 is equal to 1, find x. Okay, so unlike the examples we have seen in our previous videos were problems on expressions, but this is on equations, and then you are seeing the equality sign in the question. Okay, so we have a solution to this problem. Log 2 to base log s to base 2 plus log 3 to log 81 to base 3 is equal to 1. Okay, by now I know you should be conversant with laws or the laws of logarithm. Okay, so we'll just go straight. This we can write as log s to base 2 plus we can write this as log 3, and 81 is 3 raised to the power 4. 81 is 3 raised to the power 4 is equal to 1. Okay, 81 is 3 raised to the power 4. Now recall our law that says log am is equals to m, right? So we are going to apply it here. Log am is equals to m. Log 334 will be equal to 4. So here we have log 2 log s to base 2 plus 4 is equals to 1. So here we have log s to base 2 is equal to minus 3. When we take plus 4 this way, it becomes 1 minus 4. If we take plus 4 this way, it becomes 1 minus 4, and 1 minus 4 gives us minus 3. Here we'll apply a relationship between logarithm and indices. If you go back to our video, you see the relationship between logarithm and indices. So if you apply the relationship here, 2 raised to the power 3, s becomes 2 raised to the power of minus 3, which is equal to, here you have 1 over 2 raised to the power of 3, applying your law of indices here, and that gives us 1 over 8. Please, if you are here to be conversant with all the topics we have done before now in logarithms, please you go back and visit those videos. Here we applied again the relationship between logarithm and indices. So this transforms this logarithmic equation to an exponential equation of this form, and then you get this result. Okay, so let's solve the second example. The second example is quite straightforward. Since these bases are the same, we can say this is log x 3 times 12 equal to 2. Okay, now 3 times 12, we're applying law of logarithm. When it's the same base and it's plus, you multiply them. Okay, so at this point we say this is log x 36 equals to 2. So applying the same rule we applied here, the relationship between logarithm and indices, will transform this logarithmic equation to an exponential equation or indicial equation. And so s raised to the power of 2, this s goes and raise this as a power, equals to 36. That's what we also did here. 2 raise this as a power, which is 2 raised to the power 3 equals to x. The same thing we have applied here. And then this implies that s raised to the power of 2 is equals to 6 raised to the power of 2 and then this implies that x must be equals to 6. I know someone may want to say that from here that the answer is s is equals to 6 and s is equals to minus 6, but we have established before while we were doing the laws of indices that the value of your base must be positive. The value of your base must be positive, and that is why we cannot use minus 6 as an answer in this case. So we just take only the positive square root of 36, and that gives us 6. So take note, don't forget, the logarithm and the base are all greater than 0. Okay, or some of them are maybe equal to 0. So you just have this cannot be 0, this cannot be negative, this cannot be negative. Okay, the base cannot be negative, this cannot be negative as well. So just bear that in at the back of your mind. Alright, thank you for watching this video. Don't forget to like, to share, and to comment. See you in our next video. Bye bye.